All right, so some things in life increase exponentially. Most often we think about money, we think about things that increase in value exponentially. Can you think of anything that might increase in value over the years rather than decrease?
Getting more clothes.
Some old cars, like they'll start decreasing, but once they hit a certain point, right, they start increasing. What else? Food?
Yeah.
Okay, think about
Because I'm going to shoes.
One day my collectibles.
collectibles. Okay, but you see what I'm saying? The longer you wait, the more they're worth, right?
Yeah.
So most of these things increase exponentially, and so we use this little formula, and we can calculate after so many years how much these things are worth.
Shoes.
So we have a growth model that we use for that. Some shoes, not all shoes, like these shoes right here, I got on wouldn't be worth nothing. Oh, they're just Nikes, stank Nikes. Like they old stank. Okay, but the point is not all shoes would, but some would. You know what I'm saying?
Yeah.
Okay. So we use this little model to estimate how much stuff will be after so many years, okay? I'm going to give you the equation, and then I'm going to tell you what all of these variables in here mean.
What?
Woo, I can't stand
Woo! This is a number 1, not an L. All right. So what we have, this A is our initial amount. What does initial mean?
Original.
Beginning or original, that's right. So if I'm talking about like a collector's car or something, I'm talking about how much it was worth when it first started increasing, or how much a comic book was. You know, a lot of people collect comics or stamps or coins. How much they were worth in the beginning, that initial amount, okay?
Stamps is like 60-something cents.
Yeah, but some people collect, there's special stamps you can collect too. Yeah, things like that. So A would be how much you paid for it. Like if you went to the store and I don't know what kinds are limited edition, but anyway, let's say you went to the store and you bought one, it was $50, and in 10 years it's worth $5,000 for whatever reason. You see what I'm saying? Your initial amount would be what you paid for it there in the beginning. All right, R. This is the rate that it grows, okay? Your growth rate. Now, they're going to give it to you as a percent, but you have to change the percent. It's still growth. It's the last part of growth. So, for instance, if I told you that I have a stamp at my house that I paid $5 for that has increased 20% each year, what would my R be?
Okay, so why do you use it?
Some people collect stuff, Samoria, too, because it'll be worth a lot years down the road. Like, for instance, my great-granddaddy used to buy, when all the state coins came out, y'all remember those state quarters when they first came out, the South Carolina? Okay, so he always, every time they come out, he'd go to the bank and he'd buy like 10 of them in mint condition in the thing. Well, he didn't pay but like 25 cents for them, but today they're worth a lot more than that because they're in mint condition. You know what I'm saying? So you don't always use it, you just keep it for collectors' items. Okay. Bye. So let's say it increases 20% each year. What would your R be?
20%.
No, but you got to do it to a that's right. That was my question is, how do you change 20% to a decimal?
You move
it twice. Joseph, I need you to put that away, please. So it becomes 0.2. Yes? All right.
What?
When you change a percent to a decimal, you move the decimal place left twice. So 20% would be 0.2. 5% would be what?
0.05.
0.05. Okay? Now, there's one more variable in there that I need to define. That's that T. What do you think T means?
Total.
time. And your time needs to be in years. So if I want to know how much is it worth after 5 years, my t would be 5. Okay. Now, in what we were doing yesterday, we were using x and y. Now we're going to be using t, but that's okay. All right, so let's do an example. Y'all ready?
Yeah.
Ready or not?
They're getting wild in the dark. That's all. I'm gonna get scared because I don't like to be outside in the dark.
They did it in my house. Oh my god.
All right.
Oh yeah, that's a
At my house, I have a comic book.
This is an example.
Yeah.
Or is this for?
You like that paper?
It's a 1938 comic book.
Oh, probably early DC.
Okay. And I bought it in 2005. Who's old?
Yeah.
I thought you were
All that how you know.
In 2005, I bought this 1938 comic book for
they sold the comic book from 1938.
$2.
I remember them days back then. I used to go to the corner store.
$55.
Okay. You gonna have homework tonight?
Okay.
No, this for instant. I mean, this for
Somebody at your door.
Each year. Hit record again. All right, so let's say that every year this comic book increases 2.8%.
How you know that? How you know that?
I'm magic.
Magic Mike.
Well, we need to know how you know that.
Listen, I lost my magic.
It's in the problem. The problem literally reads, the owner of an original copy of a 1938 comic book sold it at an auction. He had bought it for $55. The value of the comic book increased at a rate of 2.8% per year.
So what's the from?
That's when he bought it. That's when he bought it.
Oh, you said that already?
Yeah.
She would have been right.
All right, shh. So my question to you is, write a model that represents this situation. Write a growth model. Okay?
Okay, I'm gonna try.
All right, so the growth model, I've already given it to you. It's A, 1 plus R to the T. Okay? What is A?
55.
55. That's what it sold for. That's the initial price. So 55.
The decimal into the problem.
Yes.
Did we already did this problem?
One. No, not for the 55. Just leave it at 55. No, we haven't.
No, I'm on the R.
So yes, the R's is a decimal, girls. So it's 2.8%, which would be what is a decimal?
2.82.
Decimal. Move it over 2, so it'd be. So when I move it over 2 places, it becomes 0.028.
Oh, because you didn't move the
2, okay? And keep the T there because they haven't said how many years yet. Right now.
Is it 1938?
No,
It is like
listen carefully. Listen, guys. When they ask you for a growth model, you leave the T in there. When they say write a model, the model still has the variable because the model is what we're going to use to plug any value of T in there. Okay? Go ahead and add your 1 plus your R.
5. This Mickey.
This is the growth model that represents that situation.
What a T at? Wait, no, what a T at? No, not that.
Move the decimal in 2.8 2 places.
Oh, she said.
This back on.
Okay, what
All right, remember, everything above the line was given. Okay, that was in the problem. This is the model. The model always keeps T in it. Okay? Now I want you to do something else, and we're going to do several more of these. Don't start. Okay. I know, because it said write a model. That's the model. Now what I want you to do, yes.
We're gonna have to grab this too.
Ricky, one thing at a time.
That's about graphic.
All right.
People still graphic.
Now, what if I said, use your model, okay? Use your model. So my model is y equals 55, 1.028, and t. Use your model to estimate how much your comic book will be worth in 10 years.
Estimate, that means estimate.
So how much is it worth in 10 years? So all we're doing is we're taking this model and we're plugging in a 10 for t. You're welcome. Okay, so y is going to be 55 times 1.028 to the 10th power. Woo! Use your calculator.
Oh, you want to do that? You want to stop?
Mm-hmm.
It's 58.
As you're getting your calculator, let me show you here also. 55, 1.028.
72.4926267.
That comic book that you paid $55 for 10 years down the road is now worth $72.49.
Something is something.
Okay. What?
That's all, that's it?
Okay.
Right, $55 you could have kept in your pocket.
But some
Could
people,
have bought food with that. Right.
some people like to do that. All right.
Ain't go Starbucks.
10 years.
All right, let's do another. We can use this same growth model, boys, to represent interest that you earn. Let's talk about just money, okay? Let's say you go to the bank, okay, and you deposit,
This is another example?
yeah, $2,000 in your bank account, okay? And the bank tells you that they'll pay you 4% annual interest, okay? The first thing I want you to do is write a growth model for what this would look like if you don't make any other transactions. You just leave it sitting there. What would the growth model look like?
Oh.
Why?
I've got it in it. Y equals A. What is A?
2,000.
2,000.
Oh, it wants to run that.
Plus,
Yes. Yes.
T.
It's that easy. Good job.
That's just the big.
Okay. So I do want, yes, this is just the growth model. So I do want to go ahead and add these together. This, by the way, once you add these two things together, this is called your growth rate. I think they might ask you that a couple of times. They might say, what's the growth rate? All right, so now I may take this even a step further and say, y'all are freshmen. You graduate in 4 years. Then you got 4 years of college. Let's say if you, as a freshman, deposited $2,000, you had a big birthday or something, got money from everybody, you put the money in your bank account, it earned this interest. How much interest do you have? Let's say you finish your 4 years of school, you finish your 4 years of college. How much money then would you have in there after, say, 8 years?
Let me see them.
Ooh, I got it.
Use your growth model to predict how much money's in your account after 8 years. Yes, ma'am.
After how many years?
8.
2,000.
That would, you're exactly right, Christian. That would mean T would equal 8.
What? I thought we was gonna have Thomas's.
You do. I'm just, so you're going to plug in an 8 for T.
Oh, yeah, I know it's
And what do you get?
37.
2,000,
737.
round it to the nearest cent because you're doing. So over 8 years, you made $737.13.
How you got that?
Okay. I put this in the count. 2,000 times 1.04 to the 8. Okay?
We do homework now?
All right.
I'm not gonna do it at home.